So let's take a little bit of a deeper look at the different types of VPN available. For site-to-site connectivity, IPsec is still the king. And for site-to-site connectivity, I would say that the router is still the king. When we take a look at remote access, this is where the ASA really gets a chance to shine. Where, again, site-to-site connectivity, you can use an ASA, but a router is going to have more features available. Just like with remote access, you could use a router, but an ASA is going to have the most features available. There's a good amount of overlap for your common functions. But if you want to do things that are specialized, this is where you'd look to each of these devices. So using a router, we have the ability to leverage GRE as a protocol. We've got the ability to support multicast. We've got the ability to support various interface types. There's a lot of neat advantages to leveraging a router, where the ASA has got a lot more capability in terms of leveraging things like clientless VPN. So let's just work through these real quick. In the last section, we said site-to-site with IPsec is maybe from router to router, router to ASA, Cisco to Cisco, Cisco to third party. Very, very standard. We've got typically static IP addresses on both sides, although they could be dynamic. And then what we're really doing there is connecting two remote networks to one another. When we take a look at remote access VPN, what's happening here is we've got a user that's out in the field perhaps, and they're trying to get back into the office. Well, we've got different approaches. One, we can use a client. This would be the Cisco AnyConnect client. And then within Cisco AnyConnect, you can use IPsec, which leverages ESP as a layer 4 transport, or you can use SSL, which uses TCP as its transport. TCP is going to be more likely to go through a PAT device, so users tend to have less trouble with SSL VPN, or the newer term would be TLS VPN, but you'll still see SSL thrown around quite a bit. ESP, we said, doesn't have a port number. If you look at the header diagram, if you just do a quick Google search and take a look at it, it's very, very simple. There's not a lot going on. So when this comes into a PAT device doesn't know what to do. So we typically encapsulate this in UDP, and we pass it over port 4500. This is called NAT traversal, or NAT-T. This works most of the time, but if somebody out there is doing filtering of the traffic that leaves their network, could be a Marriott, could be a Holiday Inn that your employees are staying at, are they going to have trouble getting to the documents and data that they need? Well, if TCP 443 is more likely to be allowed, well, maybe this is something that we should be using. You can use either, you can use both. It's really just up to you. When we take a look at clientless, this is a bit of a different approach. Let's assume that somebody doesn't have the Cisco AnyConnect client. What do they have? Just their browser. So this is really ideal for maybe somebody that was working from a kiosk, which I think would be a security risk, but again, this is just something that they kind of advertise it to work with. This could be something good for a remote worker that would normally work from the office, but they got sick and they don't want to bring that cold into the office. So they just want to get in real quick from a computer that they're not normally on. That's a good case. Another case is a non-technical user, and perhaps even some really technical users. The reason that I say non-technical is because the clientless is a bit limited. It works really, really well with web applications. It can do FTP. It can do Windows file shares. But if you want to work with other applications, besides those, it tends to be a little bit tricky. Where with the full client, everything tends to work really, really well. If you're a technical user that wants all the bells and whistles, and you don't mind the installation of a client, full client would be the way to go. Just for quick, dirty access, where somebody needs to get in from a remote device, we can support clientless. Now again, you could be doing all of these site-to-site, full client, and clientless on the same ASA. As we go through this class, we'll get into a little bit more detail on each of these, but I just wanted to introduce these at this point of the course and let you know that they were available. So again, here we are looking at site-to-site VPNs. These are traditionally our IPsec tunnels. They can go from routers to ASAs. They can go even from server to server. That's what we call transport mode, but you could take any TCP IP-based system, Windows, Linux, OS X, and build an IPsec tunnel between two boxes, and then encapsulate whatever application you want to use through that tunnel. Maybe it's remote desktop, could be FTP, it could be anything. Really pretty neat that we can use IPsec as a band-aid after the fact to secure insecure services. So site-to-site, what we typically deal with as Cisco engineers is going to be using network infrastructure. So maybe we're going from a virtual ASA on Amazon back to a router at our headquarters. Maybe we're going from a firewall in our data center to a router at a branch office. You can really mix and match this just about any way you like because IPsec is a standard. Remote access VPNs, again, with IKE version 1, you're going to need a proprietary client. Whoever the vendor is that you buy your firewall, in our case Cisco, you would use the Cisco client to establish that connection into your firewall from the outside. That connection could use IPsec, could use TLS. The example here of DTLS that you see, this is doing an SSL tunnel or TLS tunnel, but Datagram uses UDP 443. It's a bit more efficient. And we'll talk about that a bit more as we go on. In either case, regardless of what the transport is, the user is going to kick off the connection to the central site just by launching their client. It's going to prompt them for authentication. Once they authenticate, all traffic will be protected through this tunnel. Once the traffic comes into the outside interface, this firewall or router will find a security association which describes how do we decrypt this traffic. Once we know how to decrypt it, we go ahead and send the clear text out the other interface towards the inside of our network. So various VPN components. To bring up a VPN, we have to authenticate. Then both sides need to agree upon the following: encapsulation method, maybe AES, data encryption, the packet integrity. What are we going to use for key management? How are we going to handle non-repudiation? How are we going to handle application and protocol support? Do we need to push down anything like a software firewall? Are we going to push down IP addresses to those remote users? Do different types of users, say technical versus sales, get assigned different IP addresses? They could, and that can be based on access lists throughout our organization. Really pretty neat when you consider all the components we can leverage within a VPN.